The definition of concavity it goes like this. Let f be differentiable, so that's important, on an open interval I. The graph of f is concave up on I when f prime is increasing, okay, on the interval, and at concave down here when on I when f prime is decreasing. Just to keep in mind, if f prime is decreasing, f double prime is going to be negative. So if I take the derivative of a function to figure out where it's increasing or decreasing, I need to see whether the derivative is positive or negative. So they are related. That's why we look at the second derivative when we look at concavity. So one thing I just want you to keep in mind, if I took, I'm going to go over here on the side. If you imagine that you had a line that was pinned right here, and then I said to you, okay, well, I want you to move this line around that pin so that the next one, so it rotates a little bit and it goes, now if it's rotating in the counterclockwise direction right now, it's going to give me a positive slope, but it's going to be steeper. So that means the slope of this red line compared to the green line, or the second line compared to the first line, is going to have a higher value. So the value of that slope, and then if I do another line in blue here, or the third line here, then that one is also going to have a higher value of slope than the first two that I drew if I just pin it in the same spot. So as it turns, if you can imagine around that pin, it becomes steeper until it flips over to the other side, right? Now, keeping that in mind, if I look at these graphs here of a concave up curve, let f be differentiable on an open interval. If the graph of f is concave up on I, then the graph of f lies above all of the tangent lines. We've kind of discovered this already because remember when we did we used tangent lines to estimate values, right? So linearization, we realized that if the function was curved upward, it's going to be an overestimate, or excuse me, an underestimate. So like if I'm using the line, it's because the curve is always above the line of tangency except at the point of tangency. So now imagine that I want to move the point of tangency along this function to the right. What ends up happening is that the line of tangency starts rotating, and it starts rotating counterclockwise so that then the slopes become steeper and steeper. So as I'm moving the point of tangency further to the right, then the slopes also starts rotating and become more steep as we go along. And if I started over here on the left-hand side, I have a negative slope. And as I start rotating, the slopes become less steep. So closer and closer to zero, eventually becoming zero, and then starting to become positive. And as I keep moving the point of tangency to the right, because the curve is always above the function, as I move to the right, that means that the slopes will also end up being steeper because the next point is above the previous point. So that means that to place the next tangent line from left to right, you will have to increase the value of the slope of the tangent line. So that means this is a typo. To place the next, I should take the out, right? That's when it's concave up. So that means then that the slopes are increasing in value. For concave down, instead, now the slopes start rotating. They start having negative or positive values, excuse me. And as we get closer to the relative maximum here, it becomes 0. And then as soon as we get to the other side of the relative maximums, now the slopes become negative and become steeper and steeper. So then the values themselves technically become smaller because -10 is less than -1. So up here we might have a slope of -1. Down here we might have a slope of -10. So then that means that the values of the slopes are decreasing in value. And that's because I need to place the next point of tangency is going to be below the previous line of tangency. So therefore, we end up with a steeper function here as we go on this side here. And that means as we're decreasing through the function. But over here, it's the same thing. On this side over here, I have slopes that are positive. But as I move the point of tangency to the right, the slopes then become less steep until we get to 0. So the slopes of the tangent lines become closer and closer to 0 until it gets to 0 and then start becoming negative slopes. So therefore, it means that the slopes are decreasing, or the values of the slopes are decreasing. So in other words, f prime of x is decreasing. And over here, f prime of x is increasing in value. That just to show you how they relate to one another.